Hi, my name is Wade Skeen. First, I want to start out with talking about what you just watched in that YouTube video. It's kind of funny. It's a news report from a Boeing Dreamlifter that's normally stationed here at McConnell Air Force Base in Wichita, Kansas, across the runway on the other side, on the civilian side. They were coming in for a landing into Wichita, which has more airports per square mile than any other city in America. Well, they didn't pay attention to their flight management computers, so they didn't know where they were. They didn't know where they were landing, so they actually landed at an airport about 8 miles south or northeast of where they were supposed to be. The bad thing about this is the aircraft that they were flying is made to carry 787 fuselages, makes it a huge airplane. They landed in an airport that was not rated for that size aircraft, so they actually didn't even know if they were going to be able to get the aircraft back off to take off again, or if they're going to have to disassemble it and truck it to where it was supposed to be. Luckily, they were able to get the fuel load and weight down and enough to take it off and fly it back where it belonged here at McConnell Air Force Base. And I would assume those pilots probably don't have jobs anymore. So that's why this is important, what we're going to talk about today. We're going to talk about flight management computers, flight management systems. I'll refer to this as FMS for brevity going through, or FMC for flight management computer, just to save a little bit of time so I'm not having to bore you guys with long terms. So, give you a little bit of background on me. I'm 34 years old. I've been in the Air Force for 17 years. I came in at 17 years old. I started working on airplanes at that age, mostly avionics system. So I have an extended background in 4 different airframes, maintaining avionics systems that include navigation, flight controls, things like this. So this is part of what I do every day. And I'm actually a teacher where I teach students how to maintain this stuff. So we're going to talk about flight management systems. What are the 3 things that flight management systems do? They tell you where you are, where you're going, how you're going to get there. Would have been pretty important for those Boeing pilots to pay attention to, right? So, with that being said, first we're going to start out with how it knows where you are. It goes off of 2 main systems. One, everybody's probably pretty common with because we use it on our cell phones and our cars and everything else nowadays, is GPS. What's GPS? Global Positioning Systems. All GPS does is sends a signal out into space or picks a signal up from space from satellites. Once you get one satellite, it can kind of tell you where you are. As you get a second satellite, it can triangulate your position a little closer. As you get a third satellite, it can even tell you your altitude relative to sea level. From there on, the more satellites you get that can lock onto your location, the smaller the reference mistake error, I should say, the reference error gets. So once you get up to 8 or 9 satellites, it can be within 3 meters of your exact location, which is pretty amazing considering it's hundreds of miles away in space. So that's GPS. The next one's a little more complicated and is not as common in everyday use, so I'll explain it a little better. It's INS. It stands for Inertial Navigation Systems. The way a basic INS system works is on gimbals. So gimbals are nothing more than center stationary rings or squares that have a metal loop going around the outside of them. You've probably seen pictures of them at museums or science fairs or something like that. You probably just didn't pay attention to what they were. But all they do is they spin around a static axis. Well, what you'll have gimbals that'll spin this way, and then another gimbal on the internal side that'll spin this way. What these gimbals do, as they start spinning, they can sense any movement going left or right, up or down from that point. So, using our GPS data that we talked about a minute ago, we program that accelerometer or that INS unit, Inertial Navigation Unit, and we let it know where we are to start with. This is what we call our present position. We plug that present position into our Inertial Navigation Unit, and it then senses our movement from that initial present position and calculates that to tell us where we are. It's an older, more dated technology. We don't use it nearly as much as GPS nowadays, but we do still use it for our backup system and flight management systems. So hope that kind of lets you guys know where we are with INS. I know it's a little bit more complicated, and we've even gone more technologically advanced nowadays to replace those old heavy gimbals with actual ring lasers. But we're not going to get into the technicalities of that. It's beyond what we really need to cover in this class. So that tells the pilots where they are, GPS and INS. That's what we started at. Now we need to know what tells the pilots where we're going. That's where our flight management computer, or FMC, comes in. I like to relate the flight management computer for my students when I'm teaching them about this to just your regular old desktop. It's got a processor in it, just like a regular old desktop. Usually it's got a couple of processors in it, just for redundancy and safety of flight issues. It's got a power source, just like your computer does. It's got a cooling fan, just like your computer does. And it's also got routers that send out this information to the different systems and take in this information from the different systems so that it can fly the aircraft where it needs to go for you. So it's really similar to a home computer. It's just the type of information that it's processing that makes it system specific to aircraft. And this isn't just for aircraft. Submarines use this, aircraft, even tanks, things like that. A lot of military systems and non-military systems use this type of navigation system. So now the pilot knows where he is with GPS and INS. He knows where they're going because his flight management computers take that input from GPS and INS. They compute that out and they tell him where he's going or flight plan out his route for him, things like that. Now the next thing we want to talk about that's really important is how does the pilot interface with this system to tell him how to get where he wants to go? Well, this is really easy. We have display units. They're usually little screens that look like something from a 80s model computer or something like that you would think of. Even the more advanced aircraft still work off those same type screens. We usually just refer to them as CDUs, or central display units. Underneath that screen will be a keyboard. It's about this wide, about this tall, and then the screen sits right here on top of it. I wish I had a whiteboard. I'd do a little more drawing and illustration for you guys, but I'm working with what I got. This would be our equivalent to our desktop screen and keyboard. Some aircraft are even fitted with hand controllers that are almost identical to a mouse. So all of this stuff references out just like our home computer was. It's just unique in the way that it processes a certain type of information. So with these CDUs, central display units, this is where the pilot's going to look and he's going to get all of his information from fuel loads, how that's going to affect his flight plan, navigation sources, where he wants to go across the way. This is where he can input GPS coordinates. He can also track wind direction, speed, all these things that his flight management computer is processing for him. He can visually see it here, and he can also input his own information to go back to the flight management computer so it can process what the pilot wants to do. I say he just out of habit, but we all know there are plenty of female great pilots out there as well, so I don't mean to exclude anybody when I say that. I'm sorry, it's just habit. So, in conclusion, we looked at three main points. We started out with our where are we, our GPS and our INS units. And then we moved on to where are we going. We used our flight management computer to compute that information and tell us where we're going. And then we went on to our display units to interface with the flight crew so that they could then talk with the computer to better understand where they're going and how they're going to get there. So, hope you guys enjoyed this brief presentation on this really complex system, but I hope you now have a better understanding of how your pilot gets you to your destination next time you take a flight. Thank you.